Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's scribblecast of organic chemistry lectures and solutions to homework problems. Here we are going to solve a problem set that was provided at the end of the IUPAC nomenclature section. This was one of the handouts distributed in class. Here you were asked to draw the following organic molecules, and you were provided the IUPAC names of those molecules. The first name you were given was 6-butyl, 4-ethyl, 5 bracket 1-ethyl butyl, 3,7-dimethyl, 3,7-dimethyl, dimethyl decane. Now, I just want to look at this name before we attempt to solve the problem and comment on the alphabetizing. B comes before E. If you had used the E, ethyl and ethyl were tied, so then the B would make it come after nothing. But if you had used the B, then the ethyl butyl would have come after the butyl. Butyl would have been tied with butyl, and this would have been in between the butyl and ethyl. But whether you put this here or 1 over, I want to emphasize that in this course, you will not be lose any marks for whether you alphabetize with the E of the ethyl or the B of the butyl. All right. So, proceeding onwards, let's attempt to draw this structure. A decane, you always look for the root name first, and then you put the carbons for the root. A decane is 10 carbons, so here's 3, 4, 5, 6, 7, 8, 9, 10. Now, off of carbon 6, 1, 2, 3, 4, 5, 6, there is a butyl. So that's a CH2, 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 4 carbons. For carbon 4, we have an ethyl. Actually, I'm going to, let's put it down here. And carbon 3 and 7 has a methyl. Okay, now off of carbon 5, we have a butyl. So there's a butyl. And an ethyl off of number 1. So here's a CH3, CH2, CH2, and a CH. So there you have 1, 2, 3, 4, a butyl or 1-ethyl butyl. Now we've drawn all our substituents. You just put in hydrogens to make 4 carbons to every bond. Be careful when you do this. I don't want to see the wrong number of hydrogens. Producing a pentavalent carbon is not allowed and will cost you marks. And there you have it. Now your structure may look a little different, but essentially you should have similar substituents and they should be localized on the same number of carbons. The next question was draw the following molecule, 2,5-dibromo, 3,4-diisopropyl, diisopropyl, and 7,7-dimethyl. Cyclohepta, so no space, right after the methyl is cyclohepta. 1,3,5 triene. Okay, as usual, we have to find the highest priority group, and that in this case is the alkenes. And we look at the root, it's a cycloheptane derivative, so we need to draw a large cycloheptane ring. So here we go. I need 7 carbons. So there we go. I put my carbons. I'll draw a dot so you can see them easily enough. 3, 4, 5, 6, 7. So there's a cycloheptane ring. And I have double bonds at carbons 1, 3, and 5. So if I was, say, to start numbering here, let's number a ring so we can see where to put the bonds. I'm going to start here. Okay, 1, 2, 3, 4, 5, 6, 7. And you could have started anywhere around the ring. So here's a 1. Fix that. Okay, so there's the 1, the 3, and the 5. 1, 3, 5. Now I've got a 7,7-dimethyl. So there's a methyl here and a methyl here. I have a 3, 4 diisopropyl. So I have an isopropyl group here. And I have an isopropyl here. And then lastly, I have a 2, 5 dibromo. And so there you have it. 2, 5 dibromo, 3, 4 diisopropyl, 7, 7 dimethyl, cyclohepta, 1, 3, 5 triene. The next molecule you have to draw, its name can be a little confusing when you try to figure out the root. It was nona 1, 2, 3, 7, 8, 3, 7, 8, pentaene, so pentaene, and we have a 5-ine. Now the reason it's a bit confusing is the presence of the penta. You actually look at this molecule and you say, nona 1, 2, 3, 7, 8 pentaene. Is it a pentaene? Is there 5 carbons or is there 9 carbons? Well, the nona defines the length of the chain. The penta tells you the number of double bonds. So this is derived from nonane. That is, there are 9 carbons. 4, 5, 6, 7, 8, 9. And then this tells you where the 5 double bonds are. There's a double bond at carbon 1. There's a double bond at carbon 2. There's a double bond at carbon 3. There's a double bond at carbon 7. And there's a double bond at carbon 8. 5-ine means 1, 2, 3, 4, 5. A triple bond at carbon 5. So now you can put in your hydrogens. Now make sure each carbon only gets 4 bonds. The end carbon here has 2 bonds, so it needs 2 hydrogens. Fine. This carbon has 4 bonds, doesn't need any. This carbon has 4 bonds, he doesn't need any. This carbon has 1, 2, 3, he needs 1 H. This carbon has 4 bonds, doesn't need any. This carbon has 4 bonds, doesn't need any. Okay, this carbon has 3 bonds, so he can use an H. This carbon has 4 bonds, doesn't need any. This carbon has 2, so he can use 2. And there it is. Nana 1, 2, 3, 7, 8, pentaene 5-ine. And it's not a hard question once you realize that penta referred to the 5 double bonds, and nana was describing the length of the carbon chain. The next question was diisopropyl. Diisopropyl hexa 2,4-diene dioate. Diene dioate. Okay. Well, the 8 ending comes from the functional group. What functional group does that come from? 8 refers to esters. Dioate would mean 2 ester groups. And they would have isopropyls on them. And then we have a hexa 2,4-diene. Well, as per usual, I must find the longest carbon chain. Hexane, the root name means 6 carbons, so draw your 6. 1, 2, 3, 4, 5, 6. Next, we have a 2,4-diene. So 1, 2, 3, 4. Now, dioate means esters. So you put in your double bond O and your double bond O. Off of the oxygens are isopropyls. It's a diisopropyl because there's 1 isopropyl off each end. So you can draw your isopropyl groups attached to your oxygens. So they're my isopropyls. Now I just need to put in the hydrogens. This C has 3 bonds, so he has an H. This C has 3 bonds, so he has an H. This C has an H because he has 3 bonds to carbon. And likewise, this guy would have an H. And there you have it. Okay. 2 isopropyl groups, a diester with 2 double bonds. Diisopropyl, hexa 2,4-diene dioate. Excellent. The next question was a shorter name that basically tested you on whether you memorized your specialty names. NN dipropyl aniline. Do you remember what an aniline is? If you did, you would draw a benzene ring with an NH2 off of it. That is aniline. But when you say NN dipropyl, the H's are replaced by propyl groups. And so you would have CH2, CH2, CH3, CH2, CH2, CH3. And there you go, NN dipropyl aniline. The last molecule to draw was 3,5-diamino phenol. Again, another specialty name. Had to remember what a phenol was. A phenol is a benzene ring with an OH off of it. And if you use the name phenol, then the OH gets number 1. So when you say 3,5-diamino, you count around the ring, 1, 2, 3, 4, 5. Your amines, or amino groups, must appear at the 3,5 position. And there they are. So 3,5-diamino phenol. Okay, that's it for this problem set. Thank you very much.